So to do, last thing we need to talk about in chapter 3 is the tangent function. So everything that we're going to be doing here with the tangent function, we're going to approach very much the same way that we've done things for sine and cosine. So the procedures to do the three kinds of problems we've been talking about are going to be almost identical. The only different, there'll be just some small differences because the tangent function is obviously different than sine and cosine, but it'll be just minor modifications. The approach, though, to all the problems we're going to look at today are going to be the exact same. So I'm going to start by just talking about the tangent function itself. So if we talk about the tangent function, the parent function, y equals tan x, there's a couple of things that are kind of big differences from sine and cosine, right? So the first one is the domain. Remember, for sine and cosine, the domain was just all real numbers. Here, for tangent, we see that, okay, the domain is got a bunch of holes in it, right? Everywhere where the x is a odd multiple of pi over 2, the graph is undefined. So, for example, at positive pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, etc. Those are all places where the graph is undefined, as well as like negative 1 pi over 2, negative 3 pi over 2, negative 5 pi over 2, etc., etc., etc. Where the graph is undefined, what are we going to put there? A vertical asymptote. We'll show you what that looks like in a few minutes when we graph this thing. Another place where we have a little bit of difference, the range. Remember, the range for sine and cosine was both those functions, the range was bounded between -1 and +1. Here, the tangent is all real numbers. As a result, what that means is that, like, there is no maximum value because we have the graph is going to be pointing up forever. And there's no minimum value because the graph will be pointing down forever. As a result, notice what word is missing from this list of things? Amplitude, because a tangent function has no amplitude. Specifically because it doesn't have a maximum or minimum, so there is the distance from, okay, just set it right there as well. Yeah. The distance from a maximum minimum to the midline is infinite, right? Like, that's dumb. That's not an amplitude. However, the symmetry, well, sine had odd symmetry too, that's fine. Continuous, yeah, of course, we have continuity over the domain, sure. The midline, still y equals 0, same as sine and cosines was. And the period, that's different, right? What was the fundamental period for sine and cosine? 2 pi. The period for tangent is 1 pi. That's a big difference. So if I take any tangent function, the period would become pi times the absolute value c. Again, notice that's different than sine and cosine where it's 2 pi. That might be a good thing for your note card. The frequency is 1 over the period, just like sine and cosine was, but since the period is different, the frequency is different. The midline still y equals k. So let's take a moment and graph the tangent function here. And let's say we graph this from like negative 2 pi to positive 2 pi. So if I was going to graph regular old tangent, I'm going to go to my reference point sheet. I'm going to scroll down to the tangent part. And I'm going to grab the 5 points for tangent. So notice at negative pi over 2 and positive pi over 2, the function is undefined there, right? Just like we mentioned earlier when we looked at the domain. That's fine. So at negative pi over 2, we're going to put our vertical asymptote. And at positive pi over 2, we're going to put our vertical asymptote. If I go back and look at my reference points again, I also had negative pi over 4, negative 1, 0, 0, and pi over 4, positive 1. So let's plot those points. So halfway between 0 and negative pi over 2 is negative pi over 4. And then I have 0, 0. And halfway between 0 and pi over 2 is positive pi over 4. So those are the 3 points in the middle. And now I'm just going to connect those. So far, so good. Now, my instructions are always to extend your graph to fill the space provided. So looks like there's one big tick mark in between every set of asymptotes. In between the two asymptotes, right on that middle grid point, is going to be a point on the midline. To the left of that point on the midline should be something halfway in between but down at negative 1. To the right of our midline point should be something halfway in between the midline point and the next asymptote, but up at positive 1. And now we'll just kind of connect our graphs. So we follow the asymptotes up. So there's our graph. Everybody feel okay here? So if I wanted to graph a transformation of this, I might do something like, let's just say we want to graph y equals tan of 2x minus 1. So the first thing I want to do is identify the A, C, H, and K. And I remember to do that, I have to write my function in that general transformation form. So the value for my A should be 1. The value for my C should be nope. 2 is 1 over C, 1/2. My H should be 0, and my K should be -1. Everybody feel good doing that? Again, that's a skill we've practiced a bunch of times by now. So once I have those values, I'm going to write my transformation map. So Cx plus H, Ay plus K. And I'm going to take those points from my key points sheet. Now again, you'd be looking these up. Me as a math teacher have these things memorized. Do you need to memorize them? No. These are things that would be given to you on your test. Just like when we've done the homework quizzes for this chapter, I've always given you the key points in the problem, right? So it'll be the same format for your test. The test questions will be set up the same kind of way. All right, and now just like before, I'm going to take my X and plug it into X, and then take my Y and plug it in for Y. So what is negative pi over 2 times 1/2 plus 0? Negative pi over 2 times 1/2 plus 0. How do you multiply fractions? Negative pi over 4 is the correct answer. Again, we multiply fractions. Tops multiply with tops. Bottoms multiply with bottoms. So negative 1 pi times 1 is just negative pi. 2 times 2 is 4. Negative pi over 4. And if you add 0, it doesn't do anything, right? Nobody had questions about that part. Okay, then I plug the y in. So 1 times undefined minus 1. What? Well, when we write undefined there, what do we really kind of mean? Kind of mean infinity. So here, use your brain powers here. 1 times infinity minus 1. What's that? Dude, it's still infinity, right? So this is still undefined. Doesn't matter what you do to undefined in this type of transformation, it's still going to stay undefined. Everybody's okay there? Okay. Next one. 1/2 times negative pi over 4 plus 0 is 1/2 times negative pi over 4 plus 0. Negative pi over 8. Thank you. And then 1 times negative 1 minus 1 is? Negative 2. Here you go, guys. 1/2 times 0 plus 0. 1 times 1 minus, or 1 times 0 minus 1. Thank you. I knew you guys could do that one. All right. 1/2 times pi over 4 plus 0. I already did it. Just pi over 8, right? It's going to be the same as thing as if we did it with the negative. pi over 4, because all we're doing is adding 0 to it. It's like, all right. 1 times 1 minus 1? 0. And then 1/2 times pi over 2. There you go. And then undefined just stays undefined, right? Of course. So now I'll just go ahead and draw and plot. Yeah, whatever. That's going to be a mistake. I'll leave that one on there, maybe. All right, 1, 2, 3, 4. 1, 2, 3, 4. All right, let's start some plotting. So pi over 4, or I'm sorry, negative pi over 4 is here. Positive pi over 4 is here. So negative pi over 8, negative 2. 0, negative 1. Pi over 8, 0. So draw our graph. It'll look like that. Now I'm just going to fill the space. Just fill in the space, repeating the pattern. Feels very familiar, just like the problems we've done before, just the only difference is the shape of the graph is a little different, but it doesn't really matter to me. It's no big deal because it's like the same procedure. All I gotta do is plot some points. And I know it's confusing because there's pi's in there, but if I just like look at the picture, it's not so bad because I just kind of follow the pattern. Almost done, just a couple more spots to fill. Fill in my graph in. I'm already regretting how big I built my axes. What do you guys think? Not a big deal, right? Same procedure as before, ostensibly, right? The shape's a little different, but so what, right? All the procedure is the same. The technique is the same. The way we come up with the AH and K is, ACH and K is the same. The way we transform the points is the same. The way we're plotting points is the same. What's really the only difference? You have to remember what to do when it says undefined. Oh no! I'll never remember. Well, that's a good thing you have a note card then, right? All right, let's do the graph to equation problem. Okay. So remember, what are we looking for? We need to go from the graph and figure out the values for A, C, H, and K, right? But you feel good there? When we did this for sine and cosine, what's the first thing we looked for? Usually start by looking for the midline, right? So it's a little bit trickier to see the midline, but usually it's just where the graph kind of bends from one direction to the other. So like that's the midline there. Notice how it's kind of like curving up here and then like curving down there. That spot where it changes the direction that it's bending is going to be your midline point. So that just tells me K is 2. Woo! Is that basically the same still? Yep. All right. Next thing we're going to do is find the A value. For sine and cosine, the A value is linked to the amplitude. And it was just the distance from the maximum or minimum to the midline, right? Same kind of idea here, but this time we're just looking at the distance from those other 2 points that were given back to the midline. So if I'm going from like, say, 2 to 5, what does the absolute value of A have to be? 3, which tells us that the A is plus or minus 3. So far, so good? And BD, not right? Oops. Next thing we look for is the period. Well, the period's just going to be the distance from asymptote to asymptote, right? That'll be one period. So we started at negative pi and we went to 0. So how far was that? Pi. And for tangent, what's the formula for a period? It's pi times the absolute value of C, as opposed to 2 pi absolute value C. That's a difference, Mr. Kulik. I know. Be okay. Just put it on your note card to remind yourself. So what does C got to be here? Oh, come on now. This is too long. 1, right? And we always pick C to be positive. So we have C, we have K. We know A down to 2 numbers. The last thing we need to find is H and the sign for A. We're going to do it the same way. So if I go to the parent function for tangent, I'm going to choose to use the point 0, 0 because that's the point on the parent function of tangent whose x-coordinate is 0. That makes my life easier. If I look at that graph of tangent, here's 0, 0. Before tangent, the graph was pointing down. And after that midline point, the graph was pointing up. Everybody agree with that? So the parent function for tangent, I'm going to call it the down midline up. I'm going to say that's the kind of point we have there. So from our resultant function, I'm going to pick one of these midline points. You could pick any one of them, but shoot, give me the one that's labeled, where I don't have to figure out the coordinate for myself. So far, so good. If I look at that midline point, it's a up midline down. Notice that these are opposites, right? What's that going to tell me? that a is negative. Just like before, right? No big deal. And then because the x-coordinate from our parent function is 0, what is the x-coordinate from our resultant function going to be? That's got to be our h. Just like we do for sine and cosine. So if we put this all together now, y equals -3 tangent of 1 over c x minus h plus k. Oops, I need one more of those. Or if you really wanted to clean this up a little bit, you could write it that way and get rid of yourself with some sets of those parentheses. What do you guys think? Almost the exact same thing as what we've been doing. The procedure is identical. The only thing that changed was the formula for period is different than cosine and sine. And obviously, like, you know, the point on the parent function is different. But like, whoop-de-doo, Mr. Kulik. It's not a big deal, right? You guys want to do another? Yeah? Let's do it. Let's do it. I got another ready to go. All right. What brave soul is going to give me the K? Yes, sir. All right. How about the A? Who can tell me what the A is? Well, plus or minus 1. That's good. Everybody's okay there? Okay. How about the period? It's what? Well, we're going from negative pi over 4 to positive pi over 4. So pi over 2, very good. And what's the formula for the period for tangent? So what does our C have to be in this case then? 1/2. Hey, I guess we didn't make mention of this when we started. How did I know looking at this graph that I was going to be doing a tangent? Yeah, the shape of it, right? It looks dramatically different than the sine and cosine graphs, right? We got those crazy asymptotes on there. Should be easy to recognize that, right? Okay. I didn't say that expressly, but like maybe we should mention it. I don't know. All right, the last thing we need to do is figure out the sign for A and the value for H. So what point from the parent function do we use? 0, 0. What type of point is that? It's a down-up midline point. From our resultant function, what point should we pick? 0, -1 is the one I would use. Again, it's labeled for me. Any midline point would be okay. What type of midline point is 0, -1? It's a down-up, right? Kate?
Is there ever going to be like one of these where you don't have
No. You would just choose to find one. You have the graph, so you can like do whatever, find whatever point you need. So what's the sign for A gotta be? Positive. And what's the sign for H have to be? 0. Or if you wanted to simplify it down, you just call it tan 2x minus 1. What do we think? It's not too bad, right? Nah. Is it basically the same thing we've been doing? Yeah. Is all the procedures the same? Isn't that the wonderful thing about doing it this way? Is that like we can change what the function is, but the procedure is still the same. All right. So let's take one quick second. So your next problem set, what is all in that? Well, from last week, we assigned problems 1 through 14, right? And then we also have a delta math. That was also assigned last week. Today, I'm going to assign 15 to 26. I'm going to assign worksheet 4, but I only want you to do 2, 6, and 8. And I'm going to assign worksheet 5, but I only want you to do 5 and 7. Next time, we'll add the review to that. So all of this stuff is part of Sunday's problem check or homework check. Good news is you guys have 45 minutes right now to work on any of this stuff. You have all of next class is the review day. We'll talk about the test format and stuff and maybe a little bit of note card jibber jabber, but after that, free to work. So you should be able to bang out a lot of this stuff just here in school, in class, before having to really take any of it home. Everybody feel okay? Does this help outlining what to do, getting it all in one place? If you look at the details on the assignments, I always try to list it in the details. But I can't name everything inside, use the name of what to do and just list all of this stuff because it's like too many things. So, yeah.
Awesome. I can't wait.
Well, in fairness, this stuff you've known about for 10 days. And the fact if you haven't done it yet, that's a little on you, right? And the review, you have all the answers for, right? Because I give you the key with it, right?
I utilize that.
Yeah. And these ones, that's 5 problems total. Right? So it looks like a lot of things, but it's really not that many things. It's still a lot of things, I know. Yes. Absolutely. But maybe it's not as bad as it looked at first glance. I would wager you could finish easily today worksheet 4 and 5
Yeah.
before you left, and that's like 2 things straight off that list. The Delta Math, I think, is also quite easy this week.
Okay, so it's 30 questions plus the review plus the Delta Math.
That's about right.
Calculator.
Yeah, that's good adding.
No, I was on my phone.
That's embarrassing.